In our second tutorial, we will rationalize binomial denominators. So let's turn over to example 2. What if we have a binomial expression in our denominator? Here we have 5 plus the square root of 2. Now it's still breaking that rule. We cannot have a radical in the denominator, and we just finished the tutorial on how to rationalize with a monomial. So some people might just say, hey, why don't we just attack this square root of 2 by multiplying by the square root of 2 and the square root of 2 to the numerator. And that might make sense, except this is a binomial. So this square root of 2 doesn't just multiply to this square root of 2, it also multiplies to this 5. So though the square root of 2 times the square root of 2 becomes 2, the square root of 2 is just going to attach itself to the 5, and it'll still be in the denominator. So attacking a binomial with a monomial, that just doesn't do it. Let's get rid of that. We have to attack binomials with other binomials. We need to multiply this binomial by another binomial. And I wonder if you know what's going to happen, because we've dealt with conjugates before, and we know how powerful conjugates can be. When you multiply two conjugates together, the inner terms and the outer terms cancel away, and we are just left with a number. 5 plus the square root of 2, 5 minus the square root of 2. These are conjugates. All you have to do is change the middle sign. Now if I multiply the denominator by 5 minus the square root of 2, of course I'm going to multiply the numerator by the same thing, because remember, all we can do is multiply this whole expression by 1, so that's the same thing over itself. Thank you for putting them in parentheses so you can see that you're going to FOIL in the denominator and that you're going to distribute in the numerator. All right, so now that we know that we're multiplying by conjugates, let's see what happens. Let's do the numerator. 3 times 5 and 3 times negative square root of 2. 3 times 5, of course, is 15. 3 times negative square root of 2 is negative 3 square root of 2. The 3 is on the outside, the 2 is on the inside, so the 3 is on the outside, the 2 is on the inside. Let's see what happens in the denominator. Of course, I'm going to FOIL. The first term becomes 5 times 5. Of course, that's 25. Now let's look at my outer terms. My outer terms would be 5 times negative square root of 2. Well, that would be negative 5 square roots of 2. Look at my inner terms. That would become positive 5 square roots of 2. Do you see that they will cancel away? Negative 5 square root of 2, positive 5 square root of 2, they cancel away. So I don't need to multiply those. It's ultimately going to make a 0. I do need to do my last terms. Positive square root of 2 times negative square root of 2. Well, a positive times a negative, of course, is a negative. Square root of 2 times square root of 2 becomes 2. And look at that. No more radicals in the denominator. My numerator is 15 minus 3 square root of 2. These, of course, are not like terms. The denominator becomes 23. That's it. It still looks like an ugly fraction, of course, but look at that. There's no more radical in the denominator. We've gotten it to be in the numerator. It's called rationalizing. Let's try another one. I see a binomial in the denominator, so I'm going to multiply by a binomial, numerator and denominator, 1 minus the square root of 5, 1 plus the square root of 5. Have to do that to the numerator and the denominator. Let's see what happens to my numerator. Square root of 2 times 1 becomes square root of 2. Square root of 2 times square root of 5. The 2 and the 5 are both inside, so they get to be combined. I'm multiplying to get 10. Square root of 10. Let's see the let's see the denominator. 1 times 1, well, that's the first terms, that's just 1. The inner terms, the outer terms will be exact opposites, so they cancel away. The last terms, a negative times a positive is a negative. Square root of 5 times square root of 5 becomes 5. Square root of 2 and square root of 10 are not like terms. Yes, I know they're both square roots, but they do not have the same radicands, so they cannot be combined by addition. So we'll just leave that alone. 1 minus 5, of course, is negative 4. Now this is the answer, but mathematicians of course do not like minus signs to be in denominators. You cannot divide things into -4 parts. That does not make any sense. So the negative sign is going to come up to the numerator. Now if it's going to come up to the numerator, it's going to make everything in the numerator negative. So the square root of 2 becomes negative square root of 2. The positive square root of 10 becomes negative square root of 10, so that the 4 can be in the denominator. So whenever you have a negative in the denominator, please float it up to the numerator and just change all of the signs in the numerator. And there we go. Please do not think that we can reduce. We cannot reduce. These numbers are on the inside, and this number is on the outside. So they are not in corresponding parts. So that's rationalizing with a binomial denominator. Here's our last two examples. My question: why are these not simplified? I don't see any radical in the denominator, do you? Why don't you pause the video and think about this some more? Do you see a radical in the denominator? Are you thinking about it? I hope you are. Do you see a radical? You might not actually see the radical sign, but you do see the I. And what does I represent? Whoops! I is a radical. Okay, so these are not simplified because I is representing the square root of -1. So we still need to rationalize. Now, the example 4, this is a monomial. Example 5, this is a binomial. So to attack a monomial, all I need to do is multiply by a monomial. The only thing that I don't like about this problem is that an I is in the denominator. The 2 is okay. There's nothing wrong with the 2. So it's the I that needs to go away. So I'm going to multiply by I over I. The same thing over itself is 1. So I'm ultimately multiplying by 1. Let's see what happens. The numerator becomes 3I. The denominator becomes 2I squared. Now remember 2I squared, that does not last long in my work. 2I squared, this is like 2 times -1. Remember I squared is -1, so 2 times I squared becomes a -2. And now I have 3I divided by -2. I don't like this. Mathematicians do not like the negative sign in the numerator, in the denominator, so it's going to float on up and become -3I divided by +2. No negatives in the denominator. Please float them on up and put them in the numerator. That's it. That's not breaking any rules. There's no more radicals in the denominator. And our final example, this is a binomial, so I need to attack with another binomial. 1 minus 3i, 1 plus 3i. I have to do that to the top and the bottom. Now, since I put a binomial in the top and there's a binomial already here, it might make sense to put parentheses around everything. Looks like I'm foiling in the numerator and I'm foiling in the denominator. Oh boy, let's see what we got. Let's do the numerator first. 5 times 1 is 5. 5 times 3i is 15i. Inner terms, I times 1, well that's just 1i. I'll just put I. And I times 3i is 3i squared. Now 3i squared does not last long in my work. I'm going to scratch out 3i squared and put -3 because +3 times -1 becomes -3. And let's see what happens in the denominator. Now these are conjugates, so I don't need to find FOIL of FOIL. I really just need to do the first terms and the last terms, because the inner terms and outer terms will cancel away. The first terms give me 1 times 1. The last terms give me -3i times +3i, which would be -9i squared. -9i squared is going to go away. -9i squared goes away and becomes +9. So now let's see what we've got. I've got 5, -3, so that makes 2. 15i and 1i make 16i. and 1 plus 9 is 10. Perfect. So I've simplified it. I've rationalized. There's no more radical in the denominator, but one more thing can happen. I'm looking at all three locations, and all three locations are even numbers. So I should be able to cut everything in half. 2 divided by 1, 2 divided by 2 is 1. 16i divided by 2 is 8i. 10 divided by 2 is 5. Divide all by 2. And there's our final answer. So thanks for watching this tutorial on rationalizing with binomials. We'll practice our monomial technique and our binomial technique in class. Thanks for watching. See ya.